Okay, let's look at the 7-stock portfolio that I put up on D2L. So if you download the spreadsheet, you should, by watching the video on how to graph the envelope portfolios with 5 stocks, be able to do this. So I'll just quickly show you some of the results. So if I control down, these are the returns for the 7 different stocks, annualized. And this is the covariance matrix for the 7 stocks annualized. So I chose to have a constant of 1 and 3. That's like the risk-free rate, but I want to call it constant. And if I do that, I come up with these weights for portfolio X and these weights for portfolio Y. They sum to 1. That makes me feel good. Just because they sum to 1 doesn't mean that it's right, but it makes me feel good about that. And then I get the return for portfolio X. I do that by multiplying the returns down at the bottom by the weights, and I get the volatility for portfolio X by multiplying the weights times the covariance matrix times the weights again and taking the square root. I do the same thing for Y for the covariance matrix, multiply the weights times the covariance matrix times the weights again. That gives me the covariance between X and Y. So now this looks like the simple 2-asset portfolio we've seen before. Now all 7 assets are condensed down into 2 different assets, portfolio X and Y. So now we have a client comes in and they want to have, I'm going to pick a number of 15% volatility. Note I have that in blue, and that gives me the following 2 choices. Let me show you on the graph. I can either have a return right here or return right there, which is going to be above 15 or just a little bit above 5. Obviously I want the higher return, but I need to know exactly where to put my money. And put it in X and Y is not good enough. I need to know how much to put in the different stocks, and I need to know what return I'm going to get. Okay, so to do this I need to solve the quadratic equation. I'll need to have an A, a B, and a C. Okay, so A, as we've been shown, is equal to the variance of X, so that's the volatility squared, plus the variance of Y, so that's the volatility squared, minus 2 times the covariance. So that's my number for A. For B, it's going to be equal to 2 times the covariance minus 2 times the variance of Y. And then for C, it's going to be equal to the variance of Y, so this squared minus what the client wants, their variance, which would be the volatility squared. I'm going to put all of these in a nice format to the same number of digits. So just going out to 6 digits for no particular reason. So I need to find the weight of X. And the way I do that is the quadratic equation. So open parenthesis here, minus B, I'll do plus first, plus the square root of B squared minus 4 times A times C, close parenthesis, divided by 2 times A. And if I'd been thinking, if I'd been smart, I would have locked all of these down, because I'm going to have to copy this over. So you should do that as you go. And now what did I screw up? Is that, can I make that correct now? Yes, I have my parentheses on top. I need to have a parenthesis right there and get rid of that one. That should be right. And I'm going to put these in, instead of percents, I'm going to put them in number format. Doesn't really matter which one you want to do. And the return of Y is going to be equal to 1, the weight of Y is 1 minus the weight of X. And then I'm just going to copy both of these over. So this was the plus. Now let's make that minus, and those are my 2 possibilities. So the return that I could get is equal to the weight of X times the return on X, lock that down, plus the weight in Y times the return on Y. Lock that down. Now, notice this blue, I put this in blue because that's going to be an input. I really should have this in red and bold because that's going to be an output. So I want all the outputs to be in red. And I just chose that color. There's nothing magical about it. That's just what I chose to do. So it gives me the 5.88% return. And now, do I feel good about that? Well, if I go over here at 15, I'm able to click into this. I can see there's 14.73, 14.98 is 5.989, so that makes me feel really good that I nailed that one. Come over to this. That's 17.15, make sure it copied right. So if I went up to here and found 15, and I should get something close to 17.15. And I do 15.04, 17.19, so you can see that's the point on the graph. So I've called that correctly. Alright, so now let's do the weights. So the weights for GE, I'm going to take the weight in X, lock that down, times the amount of GE in portfolio X, plus the weight in Y, lock that down, times the weight of GE in portfolio Y. And I missed something there. What did I miss? It's going to be the weight in Y, lock that down, times the weight of GE in portfolio Y. Alright, so now copy that down, and Alt equal. Alt equal is going to guess wrong. I want it right there. So that's 100%. And the same thing over here. I might do it like this, equal to this weight, the weight of X. So my portfolio that I want to use, actually portfolio Y, portfolio Y is what I want to use, and, well, I'm sorry, not portfolio Y, choice 2. Choice 2 is the choice I want to use, and it is minus 2.96 in X times GE is minus 0.34 in X, plus this amount in Y times that amount in GE. And now copy this down, copy it down all the way, copy this over to make sure I'm at 100%. I am, and then I have that. So I want to have, this is going to be my choice. This is one that I want. So I'm just going to put this for now in a different color. I'm not going to, the green is the one I want there. That should be green too. So this is how I want to invest. I can tell the client, if you put these amounts in these different stocks, so if you have $1 million, a million times minus 0.48 in GE, and you'll get this return of 17%, and your volatility will be 15. Okay. So the next step, what if I have a client number 2, and they want to do something very similar. I'm going to copy all this down, Control C, Control V, but they're going to give me the return that they want. I got to spell return correctly. Oh, let me go back to this real quickly. Could they get a 5% return, I mean a 5% volatility? So if the client came in here and said, I want a 5% volatility, you put that in there, and look, it gives you this, it fails. And why? Because 5%, there's nothing there. You have to hit at least the minimum, which is around 10.52. You have to hit at least the minimum, or you're not going to have any answer because it's not possible. Alright, so we go to return. Say the client wants a return of 12%. Get rid of all this stuff. This is going to be a lot easier because my weight in X is going to be equal for return. It's going to be equal to, and you can do the math of this, the return that the client wants minus the return in portfolio Y, which is right here, divided by the return in portfolio X minus the return in portfolio Y. And then the weight of Y is 1 minus that. So my volatility, or I'm going to call it my sigma, is equal to the square root of the weight of X squared times the volatility of X plus the weight of Y squared times the volatility of Y squared, the variance of Y, plus 2 times the weight of each one times the covariance, and that would be the sigma. So if you look at this, if you're 12% return, the sigma is 10.55. Is it going to make sense over here? So if I get into this, 10.55 gives me pretty close to a 12% return. Yeah, 10.55, 12%. That's what the graph shows. That's what my results show. I feel really good about that. So now my weight in GE is going to be equal to the weight of X, same thing, lock this down, times the percent of GE in portfolio X plus the weight in Y, lock that down, times the percent of GE in portfolio Y. And now copy this down. Let's put brackets around this. Oops, didn't hit the button right. Put brackets around that. Come down here, Alt equal. Alt equal is going to guess wrong what I want to sum up, so highlight it. 100%. So yeah, if you want a 12% return, Mr. Client, you have to invest in the stocks like this, and this is the level of risk that you would get. If you want a 13% return or 14% return, whatever it happens to be. Alright, and then the next one is going to be the minimum variance portfolio. I haven't gone over this to a lot of detail, but I'm just going to go kind of quickly through it here. It's going to be the same type of setup. So let me copy this, Control C. I'll just go right here, Control V. And we want to have the least risk possible. So let me rearrange these. I'm going to just clear this out. The least risk possible, so I'll find so I need to find the weight in X first, the weight in Y, and then I can find the return and the volatility, or the sigma. Let me clear these out. I'm going to get rid of all this input stuff. I'm just going to get rid of the color, go to automatic theme. So the way I would do weight in X for this is I'm going to have, for the minimum variance, the least variance possible, the formula is going to be, you take, for the weight of X, sigma Y squared minus the covariance of X and Y, divide by the variance of X plus the variance of Y minus 2 times the covariance, and then the weight of Y is 1 minus that. Put these both in number here, and I'll do all of these. Oops, didn't want to do that. I will do all of these in percents. So just to make sure they're in percent. So the return is equal to the weight of X times the return of X plus the weight in Y times the return on Y. The volatility is equal to the square root of the weight of X squared times sigma X squared plus, you should get this formula by now, right? Sigma Y squared times, or the weight of Y squared times sigma Y squared plus 2 times the weights times the covariance, close parenthesis. And what did I screw up there? Because that 91% sigma is pretty big, so something went wrong. that squared plus that squared times that squared. I left off. Let me see where I left off. I'll just do this again. This weight times that weight times covariance. There we go. Sigma 10.51. And if you go up here and look, you can do this two ways. You can go through here. Actually, look at this. Here we see the really small sigmas. The smallest one I see there is 10.5146, and look, that's 5.26, and that's 5.36. So this should be less than 10.5146. So let's see, 10.5146 has to be less than that. 10.5137. So we got it. And then we do the same thing for the weights in each individual stock. 4 times weight in GE plus the weight Y, F4 times the weight of GE in portfolio Y. And now I just copy this down, and that's it. Just need to make that look good, and I got it. There are that should be client number 3 instead of client number 2. So in review, client number 1 comes in and says, here's the sigma that I want. So we have to choose between the 2 points. I can see them graphically, but I need to have an exact number. So to do that, I have to solve a quadratic equation. I get my points A, B, and C, and I have my 2 different possible portfolios for weights of X and Y. I see which one has the highest return, and I want to go with one with the highest return. And then I figure out the weights in the individual stocks. So this in green is, well, let me highlight, this is how the guy should invest, and he will get a 17% return if he takes a 15% standard deviation. A client could come in and want a particular return like 12%, and the solution there is a lot easier. I just have 1, and the reason you just have 1 is, look, there's a unique, if you start with return, there's only 1 point that gets you to each one of those returns. Same type of setup. And then the minimum variance portfolio, I have an equation for that, which is right here. Let me get where you can see all that. There's the equation for the minimum variance portfolio. And look, a client comes in, wants less than 11.52% return. I can give it to you, but you don't want it, because you can take the same level of risk and have a greater return. So go through here and change this return to something below 11.52 and something above it, and see that everything matches up with that graph. So that's it.